NASA's turn of events was unexpected. The James Webb Space Telescope, which left astronomers and the entire world in awe just a few weeks ago, identified the earliest galaxy in the universe. Now, it has discovered something even larger, an enormous black hole dissipating from its galaxy at a breakneck pace of 4 million miles per hour, according to NASA. This new discovery has extremely significant implications and has sparked a lot of speculation among scientists and space enthusiasts about what this means for our comprehension of the universe. The James Webb Space Telescope was sent on a mission to investigate the universe's first stars and galaxies. It has taken stunning photographs of the death of stars and galaxies 100 million years after the Big Bang. We invite you to explore these recent findings from the telescope. Remember to like and subscribe for more content like this. The most recent discovery challenges the scientific community's current understanding. Generally speaking, black holes are considered massive entities that pull in everything, even light. However, this recently discovered black hole appears to be working differently. It does not reflect light, but is instead creating brand new young stars along a fresh trail. This trail of newly formed stars has been observed following the black hole, extending an incredible 200,000 light-years. Scientists are astonished by this black hole's unusual behavior compared to others. A group led by Professor Bionda of Geoastronomy recently released a report on their findings in the Astrophysical Journal. The Hubble Space Telescope, additionally, supported these observations, implying that the black hole comes to life when it interacts with gas and cools. We are witnessing a wake-up in the shadow of the black hole. But NASA has not yet made every exciting announcement regarding the merger of galaxies. The James Webb Space Telescope captured ARP-220, an impressive galaxy merger shining among the constellations of the night sky. RP-220, the result of merging to spiral galaxies, is a phenomenon that shines brightest in infrared light, making it perfect for the James Webb's observation. The Space Telescope classifies it as a luminous infrared galaxy with an ultraviolet luminosity comparable to 1 trillion suns. In contrast, our own galaxy, the Milky Way, has an extremely low luminosity of approximately 10 billion suns. ARP-220 can be found in the Serpens constellation approximately 250 million light-years away. It is regarded as one of the brightest of the 3 closest galaxy collisions to Earth and is listed as the 220th object in an atlas of strange galaxies. About 700 million years ago, 2 spiral galaxies smashed into each other, causing a huge explosion of star formation. This resulted in a dense region, approximately 5,000 light-years across, that contains about 200 massive star clusters. Surprisingly, this small area contains more gas than the entire Milky Way. Previous radio observations by telescopes discovered about 100 supernova remnants, far more than the Hubble Space Telescope showed. The parent galaxies of ARP-220 are 1,200 light-years apart, but share the same core, which contains a star-forming ring that rotates and gives off brilliant infrared light. The most recent perspectives from the James Webb Space Telescope display a stupendous galactic merger of the 2 galaxies. Additionally, a few faint tidal tails are visible in the image, extending from the area around the merger, demonstrating the gravitational pull. Finally, the red, orange, and ochre filaments and streams between the 2 galaxies represent organic materials scattered throughout, another stunning discovery. ARP-220 confused researchers when they first identified galaxies at the edge of the universe. They were skeptical about their veracity. Some thought they might be nearby galaxies in disguise. To share the information with the scientific community, the incredible James Webb Space Telescope proved that these ancient galaxies exist. Astronomers believe the light from these galaxies has traveled more than 13.5 billion years to reach Earth, granting us a look into the distant past. These galaxies were discovered when the universe was just getting started, demonstrating how quickly the first generations of galaxies emerged. Spectral data confirmed their existence. We can't see anything beyond these galaxies, some of which are farther away than Hubble could detect. This finding is significant because it confirms one of the James Webb Space Telescope's primary tasks: to investigate the universe's origins through the moving light of the past over a 13.5 billion year span. The telescope's capacity to measure drastic redshifts sets it apart, allowing astronomers to investigate in the infrared range and examine the universe's initial galaxies. The astronomy community is buzzing with excitement, as this discovery signifies a significant turning point in the investigation and comprehension of the universe's evolution. The discovery has had a profound impact on our understanding of the universe and compelled NASA to enhance the effectiveness of existing telescopes, including the James Webb Space Telescope. To verify our understanding of the Big Bang, information gathered from the near-infrared spectrometer and the Webb's F-spectrometer camera has shown that 4 out of 6 primordial galaxies exhibit extreme redshifts, indicating that the Webb is observing them as they were 300 to 500 million years after the Big Bang. The presence of heavy elements like carbon is surprising. Considering the universe is approximately 13.8 billion years old, the existence of these galaxies suggests that we should modify our knowledge of the early universe. These new discoveries contest the existing cosmological Big Bang theory and the inflationary model, which has some flaws, such as contradicting thermodynamic principles and lacking a clear understanding of what triggered the Big Bang. The James Webb Space Telescope has found galaxies nearly as old as the Big Bang itself, which challenges everything we thought we understood about the universe's origins. Theoretical physicist Michio Kaku noted that the discovery of old galaxies by the James Webb Space Telescope has cast doubt on what we knew about the universe's beginning. Previously, it was thought that galaxies were less developed and newer than the Milky Way. These findings may indicate that we are missing important information. 6. Galaxies have been found that existed 500 million years after the Big Bang, and they are as much as 10 times larger than the Milky Way. This raises questions about whether our current theories about the universe's creation are correct. Kaku clarified that it takes billions of years to build a galaxy like the Milky Way, so it's odd to locate such massive young primordial galaxies. This discovery might necessitate rewriting textbooks and revising our understanding of the universe's inception, contrary to expectations. The James Webb Space Telescope's findings show that the Big Bang left behind more complex structures than anticipated. Scientists are at a crossroads. NASA recently mentioned a galaxy cluster in a tweet, dating back only 650 million years after the Big Bang, adding another fascinating piece to the puzzle. Astronomers have analyzed the data and concluded that this newly formed cluster is expected to expand and become comparable to the massive coma cluster A1656. This event is unique, as it is moving quickly in one direction, influencing the evolution of the galaxy. Researchers using the James Webb Space Telescope can now determine the speeds of these 7 galaxies, giving them confidence that they are part of a protocluster. To put this in perspective, NASA scientists compare these far-off galaxies to tiny specks of water from various rivers that will eventually unite to form a substantial, powerful river. This clearly demonstrates that what we formerly believed about the Big Bang is not working out as expected. The Webb telescope may uncover more data to either support or disprove the theory. Although the Big Bang did occur, what caused it is a different story, and we must wait for additional discoveries. We may be wrong about the answers. What are your thoughts on these discoveries? Share your comments in the comment section, and I hope to see you in the next video. Thank you so much for watching.